video on angle of deflection. So first off, what is it? Well, here's the first option. We have a sphere on the left travelling towards the top right. Its velocity is described according to that red vector there. After the collision with the other sphere, its positive I becomes a negative I. So it changes direction and it rebounds back. So the angle of deflection is as follows. If instead of deflecting off the other sphere, if we pretended it went straight on like so, the angle of deflection is the angle it's rotated through relative to that dotted line. In other words, the angle of deflection is just the angle in there between the dotted line and the green arrow. So how do we calculate it in this case? Well, there's the reflection. The first thing we need to do is calculate the angle that it makes before the collision. And we get that with the inverse tan of the j's over the i's using the initial velocity vector. The second thing we do is we'd calculate the angle it makes after the collision. And we do that with inverse tan of the j's over the i's with the final velocity vector for that sphere, or the velocity after the collision. Now, I put in the dotted line like so, and I'd always recommend drawing a diagram for this. The angle here then is also A. Here we go, finally. The angle A is in there, and it's A because that's an opposite angle in the cross. And then we can see that the angle of deflection is between A and B. And if we add up the three angles, they add up to 180, because that black horizontal line, the line joining the centres, is a straight line. So to calculate D, the angle of deflection, we would just calculate from 180 minus the angle B and A added together. So that's the first scenario. The second scenario is after it collides with the other sphere. It doesn't rebound back, but it continues to have a positive I direction, or it has the same I sign as it had going into the collision. Now we know the angles already. Let's look at where the angle of deflection is first though. So pretend that the sphere was travelling unimpeded. It would travel along the red dotted line, and the angle of deflection is in there. So here's how we get it in this case. You'd need to get the angle A, again inverse tan of the j's over the I for the initial velocity vector. There's the angle afterwards. And the angle between that green vector and the horizontal line would be B. I haven't got it in here because it's too cluttered, right? So the angle between the green vector and the horizontal line is the B angle. So it's the direction the sphere travels after the collision. There's the original direction. We know that that's A because they're opposite angles. Now we know that the total angle between the horizontal and the green vector is B. And we also know the angle of deflection is in there. And in this case, D plus A equals B. So to get D, we just subtract the angle B from A, the angle of deflection. Okay, that's just a summary of what it is and how to get it.